In today's lesson, we'll look at another differentiation rule called the quotient rule. The quotient rule is used when we are dividing two differentiable functions. So if we have the function y, which is the quotient of function f and function g, we follow this pattern. The derivative of y would be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. Let's take a look at an example. Here we have capital F of x, which is our function, and it is the quotient of two polynomials. To find the derivative of capital F, our pattern says we take our denominator and we multiply it by the derivative of the numerator, which is 2x plus 2. And then we subtract our numerator, which is x squared plus 2x minus 3. And we multiply that by the derivative of the denominator, which is 3x squared. And this whole thing is divided by the denominator squared, which is x cubed plus 1 all squared. So we are done calculus at this stage. Okay, from here on it's just algebraic simplification. So to find the simplified version of f prime, I'm going to multiply these two binomials together. So x cubed times 2x will be 2x to the fourth. X cubed times 2 is going to give me a positive 2x cubed. 1 times 2x is 2x, and 1 times 2 is 2. Then I'm going to multiply the 3x squared with this negative sign, and I'm going to distribute that into the binomial, or trinomial, x squared plus 2x minus 3. So that will become negative 3x to the fourth power minus 6x to the third power plus 9x squared, and this is still all divided by x cubed plus 1 all squared. Finally, I'm just going to collect like terms in my numerator. So I have a 2x to the fourth and a negative 3x to the fourth. So that will end up being a negative x to the fourth. So this will be negative x to the fourth power, so that gets rid of those. I have a 2x cubed and a negative 6x cubed, so that will be a negative 4x cubed. That gets rid of those. I have a 9x squared plus 2x plus 2, and this is all divided by my denominator of x cubed plus 1 all squared. And that would be my final answer. All right, let's take a look at another example. And in our next example, we have a radical divided by a binomial, 1 plus 2x. So the first thing I must do is I must get rid of my radical. So to do that, I am going to change that to x to the 1/2 all over 1 plus 2x. Now to take the derivative here, again, because this is a quotient of two terms, we are going to use the quotient rule. So the quotient rule says it is going to be the denominator, so y prime is going to equal my denominator, which is 1 plus 2x, times the derivative of the numerator, which is 1/2 x to the minus 1/2. Just clean that up a little bit. Minus the numerator, which is x to the 1/2, times the derivative of the denominator, all divided by the denominator squared. Now again, as in the last example, we are done calculus at this stage. The rest is just algebraic simplifying. So the first to start off with, I'm going to simplify this term right here. Now some people, because of the negative exponent, want to move it down to the bottom here, which we can't do. So what we need to do is move that negative exponent just down with the 2. So my first step, and I'll show you all the steps here, this is going to equal 1 plus 2x times 1 over 2, and now that x to the negative 1/2 will become a positive 1/2 there. I'll multiply these two terms together, and this is still over 1 plus 2x all squared. Okay, so now at the next stage, I am going to multiply these two terms together, and remember, this guy here is really over 1, so I'm just multiplying two fractions together. So I'm going to multiply the 1 plus 2x by the 1, and this is going to equal 1 plus 2x. And when I multiply the bottoms together, 1 times 2x to the 1/2 is just going to be a 2x to the 1/2 right there, minus my next term is 2x to the 1/2. And this is all over 1 plus 2x all squared. Now at this stage we have some options. We could get a common denominator in my numerator and then multiply by the reciprocal of the denominator and simplify it that way. I like to use a little bit of shortcut, and what I like to do is get rid of any fraction in my numerator. So right now I have 3 separate terms, and my only fraction in my numerator is 2x to the 1/2, so I'm going to multiply every term by 2x to the 1/2. So when doing that, this term will cancel out with that, and I will be left with just the 1 plus 2x. In my next term, 2 times 2 is going to give me 4, and x to the 1/2 times x to the 1/2 is x. And then I'm just going to write these two terms in the denominator as separate factors because I can't multiply those together. Finally, I'm just going to collect like terms, and if I collect like terms in my numerator, I am going to get 1 take away 2x all divided by 2x to the 1/2 times 1 plus 2x all squared, and that would be my final answer. In our next example, we're asked to find points on the curve y equals x divided by x minus 1 where the tangent line is parallel to the line x plus 4y equals 1. We said earlier, anytime we're asked to find points where tangent lines are parallel to something, anytime we're looking for points, we must be given the slope. So the slope is disguised inside this line, x plus 4y equals 1. So the first thing I need to do is write this line in the form of y equals mx plus b. So if I divide everything by 4, I get negative 1/4 x plus 1/4, and therefore my slope of my line is negative 1/4. Now, because my tangent line is parallel to this line, it must have the same slope, so we'll call this the slope of the tangent line, and it must also be negative 1/4. Now, when you're given a function to find a representation for the slope of the tangent line, I simply take the derivative. So y prime, and using the quotient rule, is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. If you were to simplify this derivative, you would end up getting negative 1 over x minus 1 all squared. So now we have the slope of the tangent line is negative 1/4, and we have the equation for the slope of the tangent line, which is negative 1 over x minus 1 all squared. So therefore, these two things have to be equal to each other. So in our next step, we are going to equate those two. So I'm going to say that negative 1/4 has to equal negative 1 divided by x minus 1 all squared. Now there's a number of different ways you could solve this. We see the numerators are equal, so therefore the denominators have to equal. We can cross multiply and solve however you want. If we cross multiply, we're going to end up getting the following. So if I cross multiply here, I'm going to get the negative of x minus 1 squared is equal to negative 4. Divide by negative 1, and I get x minus 1 squared is equal to 4. Again, you could either solve this by expanding the left-hand side and bringing the 4 over and solving a quadratic equation, or we could use the square root principle. And if I square root both sides right now, I'm going to get x minus 1 is equal to plus or minus 2, and therefore x is going to be 1 plus or minus 2. So my two possible values for x could be 1 plus 2, which is 3, or it could be 1 minus 2, which is negative 1. Now if we look back at the question was asking us to find points, so we know the x-coordinate of our points. To find the y-coordinates, we're just going to plug back into the original function, which was x over x minus 1. So if x was equal to 3, my y-coordinate would be y equals 3 all over 3 minus 1, which would equal 3 over 2. So my first point, where the slope of the tangent line equals negative 1/4, would be 3 and 3 over 2. And my second point, I'll just do it in a different color here, when x is negative 1, would be y equals negative 1 over negative 1 minus 1, which would simplify to be 1/2. So that point would be negative 1 and 1/2. Okay, so that concludes today's lesson. There is your assignment. Again, refer to the web page for the answers to this assignment.